In today's video, we're going to be talking about Newton's third law. After watching this video, you should be able to know what Newton's third law is and be able to just answer some questions that use the principles of Newton's third law. So let's get right into it. Newton's third law basically says for every action, there is an equal and opposite reaction. And the big key words are equal and opposite that I would say would be worth making a note of. Okay? So basically what that means is for every interaction, there's a pair of forces acting on the two objects. Okay, so forces never just happen by themselves. They come in pairs. And the size of the forces on the first object will always equal the size of the force on the second object. So if I push on the wall with 10 newtons of force, the wall pushes back on me with 10 newtons of force. The only difference is that it's opposite in direction. So if I push on the wall to the right with 10 newtons of force, the wall will push back on me with 10 newtons of force to the left. Okay, so opposite in direction but equal in numerical value. So just some examples here. A baseball bat hits a baseball just as hard as the ball hits the bat. So if you're swinging a baseball bat and you hit a baseball with, I'm just making something up, but let's say 10 newtons of force, the ball is going to hit your bat with 10 newtons of force. Well, you may say that doesn't make sense. The ball goes so much further than the bat does. Basically, the difference is that the bat is considerably heavier than the ball and that the resultant motion on the bat is much less than the ball. And you have to imagine, too, the bat is in your hand, so you're holding it, so you kind of are part of that mass, if you will. You're one with the bat in a way. Another example would be, let's say you're driving on the road and a bug hits the windshield of a car. Believe it or not, the bug experiences the same force from the car as the car does from the bug. Okay, so they both are experiencing the same amount of force, just opposite in directions. But you may say, well, dang, how come the bug gets splattered and the car, it's like no big deal? Well, again, the car is just so much heavier than the bug that the resultant motion on the car is much less than on the bug. Remember, an acceleration is dependent upon the force and the mass. So the mass, it's inversely proportional to the mass. So as the mass goes up, the acceleration goes down. So if you compare the mass of, say, a car to a fly, well, it's quite a bit different, right? So here's just an example problem I could throw at you. It says, many people are familiar with the fact that a rifle recoils when fired. Okay, so when you shoot a gun, it has some recoil to it. This recoil is the result of action-reaction force pairs. Okay, so Newton's third law. A gunpowder explosion creates hot gases that expand outward, allowing the rifle to push forward on the bullet. Okay, so there's a force in the bullet to push it forward. And consistent with Newton's third law of motion, the bullet pushes backwards upon the rifle, causing that recoil. The acceleration of the recoiling rifle is A, greater than the acceleration of the bullet, B, smaller than the acceleration of the bullet, or C, the same size as the acceleration of the bullet. Now notice in all these questions I'm asking about the acceleration, not the force. Okay, so the answer is B, the acceleration on the rifle itself is much smaller than the acceleration of the bullet. And the reason is the rifle is considerably heavier than, say, the bullet is. Had I asked, which experienced a greater force, well, that's a trick question. They both experience the same amount of force. There would be no difference because Newton's third law says that they both experience the same amount of force. It's just opposite in their directions. That actually takes care of this video. I will see you guys next time.